Good evening. Last but not least, my name is Todd Lowenstein. I am Senior Director of Sales at CastLabs Inc., a Berlin-based multi-DRM provider. And I'm here to tell you tonight a little bit about DRM and demystify it for you. My goal tonight, after getting through these slides, is to make this so much fun that you're going to go and make this part of your cocktail conversation. So let's start. If you're looking to find out a little bit about how DRM fits into the streaming workflow, I'm here to tell you a little bit about this. It's to help you reach your full audience with protected content. And so why are you going to use digital rights management? If you have any desire to supply premium content online, you'll eventually encounter the need to use DRM. And DRM is part of a company's monetization strategy. It's also part of its piracy protection strategy. Studios require that DRM is used to stream their content to ensure assets are protected. And there are two ways of doing this. One is the software-based implementation, which is example would be part of the operating system of the device, whether it's a mobile device or hardware or a desktop device. And then there's the HD or 4K hardware requirement. And the DRM application operations actually happen within the device's chipset itself. It's much more difficult to compromise DRM if it's part of the chipset. So I'm going to give you a little bit of background about how DRM starts and how it finishes. It starts in the encryption and the encoding and the packaging portion of taking a mezzanine file, encrypting it. Obviously, most of us here know what encryption involves. It's scrambling using algorithms. And this is, you see on the left, what a typical unprotected, unencrypted video looks like, and on the right, what an encrypted video looks like. So where do we put DRM in this process in terms of the encryption portion and the packaging portion? Well, you take a source video. In the encryption, you'll encrypt it using either AES 128 or Common Encryption, also known as CENC. Upload the content up to the content delivery network, and before you actually do that, you can actually package it for things like HLS, Dash, smooth streaming. And then you're going to take the encryption key and actually ingest it into the DRM licensing server. Now, encryption keys are very difficult to break. It's usually part of an algorithm, and you're using it to maximize the security. There are 3.4 times 10 to the 38th power possible key combinations. So it would take you a very long time to break a lot of encryption. But cracking one key does not crack all of them, so remember that. The DRM licensing server actually stores the content encrypted keys, and the keys are actually encrypted before they're sent up to the server. This securely delivers the content licenses in containing the video's encryption key, specific info for the DRM system for a particular player, particular device, the metadata for the license, and the license itself is usually encrypted to keep it from being intercepted during transmission. Now, DRM can be actually operated in-house on a server, or it can be cloud-based. Like, for example, our company is cloud-based DRM, multi-DRM service. But you must have the individual DRM systems implemented in order to take care of all the different devices and platforms that are out there. A lot of people think there's more standardization. There's actually more fragmented, because it's every day there's more devices that come out, more operating systems, or more browsers. You have chaos, basically. So examples that are out there include PlayReady from Microsoft, Google Widevine, FairPlay from Apple, CMLA-OMA, which is a software-based DRM, Marlin, and Adobe Access. But they're not compatible with one another. It's important to remember. Now, how does DRM actually work? When a user presses play, a request is made to the DRM provider or the DRM server. The DRM licensing server will actually make a callback to the database where the content provider keeps their user information, and they'll receive authentication yes or no to allow the key to be released. If the key is released, the content delivery network will actually send the content, the encrypted content, and then the user will be given a license, either, again, software or hardware-based license, to actually decrypt the content and play it back. Once the content and license are delivered to a user's device, as I mentioned, decryption can happen, but it securely happen. A lot of times, encryption alone will not be good enough, obviously, for studios. They want something much more secure. And you need to ensure that the user cannot access the encryption key or the decrypted content in the device's memory. And I'll explain to you in a second what the difference is between software and hardware-based DRM in more detail. In the hardware-based process, the player software actually receives the license and places it within the device's chipset itself. It decrypts the license to access the key, and the user key actually decrypts and decodes the content. And so the content is actually pushed from the chipset to the actual screen of the device. Studios typically require hardware-protected DRM, especially for 720 on up and for 4K for sure. Now, in the software process, it's very similar, except it's actually pushed to the memory of the device and the actual OS. The player software pushes it then to the playback screen, and the information, unfortunately, is potentially accessible in the device's memory, so it's not quite as secure. And you need code obfuscation for a mobile player in their applications to prevent this from happening. Again, studios typically only allow SD quality content when using software-protected DRM. I'll tell you a little bit about video players in DRM. Not every player, there's lots of players out there, but not every player will support DRM-protected content. You must have specific functionality to be able to read the different DRMs that are out there, DRM schemes and licenses that are out there, and decrypt the content for playback. Players support DRM won't support every system on the market, so it's important that you check their compatibility for this. The most commonly used DRM schemes that are out there, as I mentioned, are Microsoft PlayReady, Google Widevine, Fairplay Streaming from Apple, Adobe Access or Primetime, Marlin, and CMLA-OMA. And there are some other players out there, but those are that covers probably 95 to 98% of the market that's out there. So what's the difference between the different DRM systems? In terms of license delivery, the format delivery method of the DRM licensing and the content keys differ from each system, making them incompatible to use one and not the other, and use one and the other. And security levels are different, as I mentioned. Some DRM systems actually work with hardware protection, others work with software protection. For example, CMLA-OMA is a software-protected DRM system. And it can affect the content allowed by the studios. So it's important that you understand this. Note on common encryption. The ISO standardized method for DRM encryption and processes enables playback from for sync devices across multiple DRM systems. Most DRM schemes will actually be able to use common encryption. The only one that is not right now for the major ones is Apple Fairplay, which uses AES 128, Advanced Encryption Standard. Only one content file set is needed, and that's very helpful. You don't have to re-encrypt over and over again your content. And actually helps simplify what is a very fragmented DRM market. Also, the transport layers that you use will vary based on the DRM schemes that you use. A lot of the world is moving towards Dash. You're all familiar with that. So PlayReady, Widevine, Marlin, Primetime, CMLA-OMA all work with Dash. Microsoft's format of PlayReady and Smooth Streaming also work well, and Smooth Streaming and Dash are very comparable transport layers. And HLS is obviously used for fair play. Apple prefers that. Apple does not allow for Dash over cellular networks using Dash. So, DRM support on platforms and devices. DRM devices and platforms support different DRM systems, and the challenge is actually to navigate all the different DRMs that are out there in a very fractured market. Again, it's getting more complicated, not less. And it's not really about the DRMs, it's about the devices and the browsers and the platforms that it supports. So how do you cover the most devices and platforms out there? Well, HTML5 browsers, like Widevine, Adobe Primetime, Widevine, PlayReady, and FairPlay are all supported in HTML5 browsers. Flash uses Primetime, but HTML5 is the way forward in this. And then Silverlight uses PlayReady, obviously, being a Microsoft product. Mobile devices. Widevine is used for Android 4.3 and higher. And iOS, FairPlay is now the new standard for iOS devices. For earlier Android devices, we use CM, for example. And why can't I just use browsers? Well, sometimes the encrypted media extensions are not supported within browsers. So for example, Chrome does have it, but Safari does not have it. All the different set-top boxes and TVs that are out there use different DRM schemes. Some of them have native players within them. Chromecast uses Widevine and PlayReady. Apple TV uses FairPlay, obviously. Amazon Fire actually uses PlayReady. PlayStation uses PlayReady and Marlin, and Xbox One uses PlayReady. And then the Samsung TVs uses PlayReady, and Smart TVs use PlayReady, Widevine, as well as the Smart TV Alliance devices use PlayReady and Widevine Classic. Android TV uses Widevine, PlayReady, and then HBB uses common encrypted DRMs like PlayReady, Widevine, Marlin, Primetime, and CMLA-OMA. So SDKs are used to enable more DRM systems out there. There are a number of examples on this. Microsoft has their player, the PlayReady player SDK. Google's Widevine has their modular SDK. Adobe has their Primetime SDK. And our company, CastLabs, actually supports many different DRM schemes on iOS and Android, as well as desktop. We have an HTML5 compatible browser that will support Dash, it'll support HLS, smooth streaming, and the various DRM schemes that are out there. So streaming content to multi-screens carries numerous DRM considerations. The more screens you have, the more complicated it gets. But you don't want to leave any users out there, do you? So tackling DRM can be a challenge. And with some help from companies that are knowledgeable, DRM can actually be a pleasant and friendly experience. So if you need DRM solutions, our company is here. We have a multi-DRM platform, cloud-based, distributed over AWS, multi-regional, multiple instances. We are basically a CDN of DRM. Plus we supply to you with everything from a video toolkit for encryption, encoding, and packaging to players for desktop, iOS, and Android devices. And I'm here to answer any questions you might have about DRM. Hopefully you're a little bit more knowledgeable than when I started. So, anybody have any questions about DRM? None? Okay, great. Thank you for your time today.